right. I will grade those and have them for you tomorrow so we can see how you did. All right, we need to talk about accuracy, precision, significant digits, and significant digit rules. We have our work cut out for us today because y'all took entirely too long on that sucker.
Can we get that in English?
All right, if we don't finish, if we do not finish, y'all are going to have to YouTube the rest of the lesson because we will finish before the period today.
I think first period is shorter.
It is by 5 minutes, but that's it. Y'all are just slower. Y'all take longer to write and to do the quiz. Y'all are only smaller by one person than four.
We're thorough. We'd like to check our answers.
Okay. All right, we'll go with y'all are thorough. All right, so we're going to talk about significant digits today. Accuracy. Accuracy is being able to get the accepted value or the correct answer. So today we're hoping that y'all are very accurate on the quiz because y'all are shooting for the correct answers. Now, the word that we use interchangeably all the time in the English language that does not mean the same thing in science class is precision. Precision is the ability to reproduce data repeatedly. All right. Now, if you're reproducing data repeatedly, you get the same answer more than once. So, if you always score a B on the test, you're precise. Some of you will score A's, B's, C's, D's. You are not precise because you're not scoring the same thing all the time. Those of you who always score a B are reproducing the same thing over and over again. That's precision. Now, an easy way to illustrate this is with a dartboard. So catch up with me and I'll show you that. Right there? No?
I'm so sorry.
Ooh, yeah, it's that.
It was an accident.
Yes, well, it's an accident. However, that does not mitigate the $10 graduate speaker that just flew across the room. Now, if you're going to do that, you're going to need to sit on the front of a row instead of near the glassware. You're not even doing a lab, and you managed to break one. So maybe you should come sit up here in front of Emma.
In front of Emma.
Yeah, somewhere somewhere's not near, or beside Tyshawn. Somewhere's not near breakables.
I don't think Emma really wants me over there right
She
now.
may not. But somewhere's not near the glassware that I now have to clean up. Okay?
She loves it.
And I should really get points for not freaking out. Because I have a tendency to yell. And I didn't right then. So I should get major points.
Well, I want a bunch of like your quotes in a t-shirt.
I
want like a bunch of your quotes on a t-shirt.
I just wanted a bunch of
Because you should have been here the day someone unplugged all these cords when they tripped over them after I told them not to come this way. Probably should have got fired. Alright, so let's say that I threw 3 arrows at my dartboard and they landed here, here, and here. How did I do? Am I accurate? No, I didn't do so good. I'm not accurate. Am I precise? No, I didn't manage to get the darts anywhere close to each other. So I'm not precise either. Now, what if I threw my darts and I did that? Am I accurate? No, because where's accuracy on a dartboard? In the center. So I'm not accurate. Am I precise?
Yes.
Yes, because I did manage to get them all in the same area of the dartboard, so I did well. Now, if I want accuracy and precision, where do I need all these darts to wind up? In the center. I am precise and I am accurate. Okay? Now, with data, you don't have to have the exact same numbers, but they should be pretty close, okay? So let's say that the density of water is 0.998 grams per milliliter, all right? And your lab data was 0.996, 0.989, and 0.994. Would that be close enough to be considered accurate and precise?
No.
See, and a lot of students say no to me on that, and that's why I wanted to point this out, okay? This is both accurate and precise, all right? This number is going to round that to what? 0.99. That's in the second decimal place. Our scales in this room only read to the second decimal place. So all of those are 0.99s. That is as good as any scale in this room reads. So it's fine, okay? So don't look at these numbers and go, oh, that's a 6, that's not close enough, and that's not close enough. They're all fine. Now, if you had 0.8, 0.7, 0.6, then yes, I'd go, no, that's terrible. But those are all close enough to not get bent out of shape, okay? The numbers do not have to be exact in all of those decimal places, okay? So if you had numbers like, just to give you something that varies, 0.67, 0.75, and 0.84, okay? These, I would say, are not accurate and not precise, okay? Those would be too far off, okay? Just to give you something to illustrate some difference. Does that help? Okay? But these are much closer together. Put it this way, if we did a lab and y'all gave me this, I'd be pretty doggone excited in a first year class. This is more than normal. There.
In other words, Friday we need to do.
Well, you're going to do a block of wood, 2 blocks of wood. Okay? We're going to see what we come up with. I'm always amazed at the range of densities we get with the blocks of wood. All right. So we're going to read the scales, the graduated cylinders, the rulers, and the thermometers. The rulers and the triple beam balances work this way. Okay? All right, the graduated cylinders and the thermometers will read the same way. Now, you're going to be at a disadvantage, Jordan, because I let you read them wrong the entire year in physical science. So you've got to throw out everything you did wrong last year and learn to read them correctly. Now, on the triple beam balance, let's just say for a minute, we have a 20 at the top. We have a 100 on the heaviest weight. And on the bottom, you have a slide, and it's at 4 and 5. And it's there. Now, we're going to read significant digits. Now, a significant digit is all known digits plus one guess. That one guess is what kills people in my classroom when we do a lab. They do the known digits without difficulty. That's what Jordan did in physical science last year. It's that one guess that kills us. Okay? So when we read the equipment, we have to put in a guess. What do I mean by a guess? When we look up here at the triple beam balance, what do we always read first? We all read this in other classes. First of all, is there anybody who has not read a triple beam balance? I'm always appalled at the number of people who stick their hands in the air and go, I've never touched one. Really? When you go to the lab tomorrow, if you do not know what you're doing, please raise your hand and have me come over and help you if your partner has no clue either. Okay? And we will learn to use the triple beam balance tomorrow. All right? So, essentially, you're adding the three beams together. Okay? You're going to move the middle one first, then you're going to move the top one, and then you're going to move the bottom one. Okay? So, you're going to add the three masses together to get the total mass. So, if I have 100 plus 20 plus this bottom mass, we're going to add them up. That's a basic synopsis for those of you who've never done this before. So, we have 100 plus 20 plus, what do I know this is? All right, we know we're between 4 and 5, so I know it's 4. Now, this is the trick to reading the equipment. This is the hundreds place. This is the tens. This is the ones place. So that means these little things are the what? What comes after the ones in math class? That's what y'all call them? Y'all must be right in math class. What comes after ones in math? Not negatives, they're not zeros. What is that place after the decimal called? Tens. Okay.
I said it first.
I know, it was all those other wrong answers that had me thrown there for a minute. Okay, the tenths were the right answers. It was all those other years before that. They were all bad too. I know. You've never had a good teacher. Okay, yeah, exactly. So what happened between all those other years then? You forgot all that good stuff you learned? Okay. Okay, so they're the tenths place. All right, so all of our known digits are through the tenths. So if we know the tenths, what's going to be the guess? The hundredths. Okay, so the guess has to be in the hundredths place. So what do we know? 100 plus 20 plus 4. How many tenths do we know? That's 0.1. 0.2, 0.3, 0.4, 0.5. Am I up to the 0.6? No. So I know 4.5. So if I add that up, I get 124.5. So my guess has to be in the hundredths place because I know the tenths. Okay? Let me change colors here. All right, I know the tenths, so the guess is the hundredths. Okay, now you need to envision numbers 1 through 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Right there between the 0.5 and the 0.6. It is your guess. I can't tell you the number's wrong. If it's halfway, your guess should be a 5. Does that little needle look like it's halfway? No? Does it look like it's less than halfway? Does it look like it's more than halfway?
Yes.
Okay, if it was halfway, we'd put a 5 here for the guess. If it's less than halfway, we'd pick a number 1 to 4, depending on how close you think it is to this line right here. If you think it's really close to that line, I might go like 0.1 or 0.2. If you think it's closer to halfway, I might go 0.3 or 0.4. If you think it's smack dab on halfway, I'd go 5. All right? You said it's more than halfway. So I'm going to pick 0.6, 0.7, 0.8, or 0.9. If I think it's really close to 0.6, I'm going to go 0.8 or 0.9. If it's a little less, I might go 0.6 or 0.7. But it's your guess. It's what you think it is based on where you think that needle is pointing on the scale. Then if you think it's a 6, you put a guess of a 6 there. If you thought it was a 7, you'd put a 7 there. It's your guess. Okay? Now, that's for a ruler and a triple beam balance because they both read what? They both read to the tenths place. So our guess has to be in the hundredths. Now, the other 2 pieces of equipment we have are Daniela's favorite, the graduated cylinder
I love these.
and the thermometer. If you can't spell it, it's spelled thermo and meter. All right, the graduated cylinder and the thermometer. All right, the graduated cylinder and the thermometer. Now, they both read the exact same way. So I'm just going to draw the graduated cylinder. All right, so let's say I put some water in here. Where do we read the water in a graduated cylinder? The top, the middle, the bottom? Read the bottom. It's called the bottom of the meniscus. Okay, it's called the bottom of the meniscus.
Where's that word from?
I have the foggiest idea. All right, now.
Oh, yeah, knee. Yeah.
Huh?
It's in your knee.
Now, there's our meniscus. This is the what place?
The tenth.
That's the tens. So that means these lines are the what place? What comes after the tens in math class?
Ones.
The ones place. Okay? So if I'm only reading the ones on these lines, where's my guess going to be this time?
The 100. The 100.
Let's go back over here. All right. What came after the ones?
Oh, the tens.
Okay.
Okay.
So, whoops, wrong way, stupid. All right. So, if we read the ones this time, the guess will be the tenths. So, if this is 30, this will be 30 what? This will be
32.
30,
3,
30,
4,
30.
5.
So, based on our meniscus, what am I past? You said this was 30,
4,
and this was 30.
6.
The one that's longer is always the middle one. That's always 35.
Oh, I thought the red one was longer.
No, that's the bottom of the meniscus. I'm just trying to emphasize it. All right, so where are we past? The red is just the bottom of the meniscus. So we're past what?
34.
We're past 34. So 34, that's our known numbers. Now, we get a guess. Point, you have to tell me how close is it to 34 or to 35? Because you can look at that and go, is it closer to 34 or is it closer to 35? What do you think, Shatoria? Do you think it's halfway? Do you think it's closer to 34? Do you think it's closer to 35? Okay, so what guess would you give me to say that? Out of 1 through 9. I think 5. I think 5 is a good choice. I think it's pretty close to halfway. Okay? If I'd have gone slightly more, I'd have said 6. I wouldn't have given it much more than 6 because I think it's pretty close to halfway. But I think 5 is a good choice. Okay? Questions? Thermometers work the exact same way. Any questions? Because I'm going to give you practice with this for homework tonight. Let's do another. You want one like this? Or you want one like the scale? Okay? All right, the green is the bottom of the meniscus to make it a little easier for you to see where the bottom of the line is. All right, read it for me and tell me what it says.
I say 2.
76.2.
Yeah. Oh, that's very nice.
All right, so what do we know? All right, this is 70 and that's 80. So these are the 10s. So this would be 71, 72, 73, 74, 75, 76, 77. So what are we past, Ashaya? What are we definitely past? What number are we past on the piece of glassware? No. Just on the sides.
What are we past?
What's the known digit that we're past? $75. We're past 75. Are we past 76? Is the water level higher than 76?
Yes.
Is it higher than 77?
Okay.
Now, remember, we can't read the top. We got to read the absolute bottom. Is the absolute bottom past 77? No. So your known digit is 76. Okay? Now you get a guess. So point, is it closer to 76 or is it closer to 77? Okay. Now you use the 1 through 9. If it's closer to 76, you want to eliminate 5 through 9. So you're thinking about 1, 2, 3, 4. Which number do you think would accurately represent how close it is to 76?
4.
I think 4 is a little high, but if you think 4 works, then put 4.
Okay, what about 2?
I think 2 is a better number. Because it's not quite at 76, but it's pretty close to 76. So 2 is pretty close to 76. Okay? Questions?
If you read the absolute bottom, is it for anything?
Say what now?
If you read the absolute bottom, is it just for anything?
This would be for a graduated cylinder or thermometer. Beakers, we generally don't read volumes on because they're estimates. They just put numbers on the side to give you a rough estimate of what the volume is. you would never use a beaker to read the volume. All right, questions. All right, let's talk significant digit rules. I'm going to give you homework with this to practice. All right, significant digit rules. There's 6 of them. And we're going to cruise through these pretty quick. And like I said, if we don't get through them, you're going to have to do YouTube tonight with fourth period's notes. All right, number 1. If I'm blind. All non-zero digits are significant. All non-zero digits are significant. Now, what do I mean by non-zero digits?
0.1, 0.2, 0.3.
Doesn't even have to have a decimal. Like 458 would have 3 significant digits because they're non-zero. They're any number other than what number? 0. Now, we could do like Emma said and put a decimal in it. I could have 12.5. Doesn't matter if it has a decimal in it. It would have 3 significant digits because 1, 2, and 5 are all not 0 digits. They're all significant numbers. Okay? That makes sense. All right.
So like 10 has 1 significant.
Hold on. The remaining 5 rules are about the 0. Hold that thought. Rule 1 was only about the ones that are not 0. The remaining 5 rules are about the 0. Rule 2 is probably the second easiest rule. All zeros between non-zero digits are significant. So if you have a number like 4,004, where are the zeros at? They're in the middle. They're automatically significant, so there are 4 significant digits there. Now, what if we put in a decimal? What if I make it 40.04? There would be how many? 4. There's still 4 because these zeros are where? They're in the middle. So there's 4. That decimal doesn't affect anything. We're going to talk about some rules with decimals in a few minutes, and people are going to go, Ms. Wall, isn't that a placeholder? Isn't that before or after a decimal? And I'm going to be like, no. Where are the zeros at? They're still where? They're in the middle. They're between the 2 4s. Okay? So anytime the zeros are between non-zero digits, they are significant. You with me so far? Okay. Now, number 3 is Emma's question about the number 10. Okay? Number 10. All zeros to the right of a non-zero digit, but the left of an understood decimal point. Okay? An understood decimal point. Meaning, you know it has a decimal, but it's not written there. So if I said to y'all, where's the decimal? Y'all are like, it's at the end, Miss Wall. But I didn't write it. That 0 is not significant. So in this case, Emma's 10 would have how many significant digits? 1. There's only 1 significant digit. If I said 400, there would only be 1. But let's change it up for a second and say I wrote the decimal. Let's say I put 400 and I put a decimal point there. What happens when I put the decimal there?
It's still, or it's 3.
It's just 1.
Would it still be 3 because it's a 0?
I made the 0 significant when I put the decimal there. The difference is we assume that these have been rounded off when I don't write the decimal. When I put the decimal there, we assume that those decimals were measured to that actual place on the equipment, and it was not rounded off, and so those zeros are significant. So when you actually write the decimal in and put the decimal there, those zeros become significant. When you don't and you round them off like I did here and here, they are not significant. Okay? You with me on that? Okay, because I need to turn the page to the other three rules. Because I can scale back the homework as long as we get the 6 rules in. I can live with scaling it back, but I'd really like you to have the rules so you don't have to watch the video. Come on, shot. Faster. Okay. All right, number 4. In numbers less than 1, the 0 to the left of the decimal is not significant. In numbers less than 1, the 0 to the left of the decimal is not significant. That's that 0 I drew in the box. That 0 has no function. It's the same thing as writing that, right? I can write 0.17 or I can just write 0.17. Those numbers mean the same thing, right? So why do we ever write that 0 at the front?
Place value.
I always type it on the test. So y'all don't miss the decimal point. It's a billboard. It's like, woo, don't miss the decimal point. That's all it's there for. Make sure you notice there's a decimal place. It's advertising. Don't miss the decimal. So it is not significant. That 1 and 7 are significant because they're non-zero. But that 0 at the front serves no function other than advertising. There's a decimal behind me. Pay attention. That's its only purpose. Like my busted up graduate cylinder over there. We need to do a lab. Somebody wiped it out with a notebook.
The blinder.
2 wipeouts.
I'm trying to be real patient over here today.
Well, you can answer this one. What time is this period over?
9:50, if they ring the bell at the right time. I'm trying really hard to get this in before they ring the bell.
Sorry, we're gonna.
No, you're fine. You're fine. All right, so if we look at this right here, in numbers less than 1, the zeros to the left of the non-zero digit, I'm talking about these right here, the left of the non-zero digit, but the right of this decimal point, the right of that decimal point, those are not significant. Those are placeholders. You might remember math class from probably middle school, maybe late elementary school. Your teacher's calling those placeholders at some point in your lifetime. Okay? Those are placeholders. Placeholders are not significant. So how many significant digits would I have in that number that I wrote there on the board? Would that very first 0 be significant?
No.
No, why not?
Advertising.
It's advertising. The 2 zeros that I boxed in are the placeholders, right? And why is the 2 and the 5 significant?
Because
They're non-zero. So there's 2. All right. The last one is for numbers to the right of the decimal.
Students, when the bell rings, we will have grab and go today. Grab and go breakfast is for students who did not receive breakfast this morning. If you received breakfast this morning, you will not be able to get grab and go and you will not have an excuse back to class. Only students who have tickets from their teachers can go to grab and go. We're going to delay ringing the bell for another minute, so please hold them in your class until you hear a bell so that it gives teachers time to give those tickets to students who need to go to grab and go. Please give those tickets out at this time.
Hang on 1 second, I'll give out grab and go tickets if you need one. All right, so all zeros to the right of the decimal. To the right of the decimal and a non-zero digit are significant. Now, you need to tell me what doing this work to. 'Cause you don't.
Why did we?
Everybody give it to you twice. Give me those back.
Wait, what?
I said, give them that twice, so here, this round. I'm supposed to walk through, did everybody get 2 worksheets?
Yeah.
Okay, so, I'm thinking about grabbing, go and give it about twice. So, for homework, on the picture page, everybody turn the picture page out. On the bottom, that middle graduated cylinder, mark it out. You're doing the one on the left and the one on the right. On the back, you're doing the A and the C. Do A and C, the rest of them mark out, we don't have those. Okay, A and C. On the paper that I just handed you, that I tried to hand everybody twice, I want you to do 1 through 20 at the top. Okay, don't mark out anything else, we're gonna do the rest of them, just do 1 through 20 for tonight. Okay? On the 1 through 20. Everybody has one, got a front and back. We're only doing 1 through 20.
And you said on the picture one
Not to do the middle one and do A and C on the back. Okay, we're only reading the ones that we have in the room.
And that's all we do.
What about
Yes. The what? The front, the 3 at the top, that is the balances. A and C at the bottom, A and C on the back. Okay? Everybody got it?
You said,